today's topic, which is heights and distances. Here we will talk about right angled triangle, right angled at B. So here in this case, we have our initial arm, which is arm AB. Then we have our arm AC, which is side opposite to 90 degree, which is called as hypotenuse. Since we have considered our initial arm as our arm AB and arm AC is our terminal arm, thus our angle is in this direction. So this angle, which is angle A, has been considered as angle theta, the Greek letter theta. So here in this case, we want to talk about trigonometric function. The most basic trigonometric functions that we have are sine, cos, and tan. So here in this triangle, sine of angle theta would be opposite. So here in this case, the adjacent side, which is the initial arm, would be called as the adjacent side. So here we want to call AB as the adjacent side, ADJACE, adjacent side. Side BC is our opposite side, and side opposite to hypotenuse is always the largest side, which is the side opposite to 90 degree is the hypotenuse, which is the largest side, hypotenuse. So sine function is the most basic function, and the trigonometric functions are nothing but the ratios of the sides of a right angle triangle. So for us, sine theta is opposite, which is, let's write opposite over hypotenuse, which is O. So opposite is BC and hypotenuse is AC. So our sine function is BC over AC. Our cos function, which is nothing but complementary of sine, which is cosine, which is shortened to call it cos. So when we are talking about cos theta, we say adjacent over hypotenuse. It is the ratio of adjacent and hypotenuse side. Hypotenuse for us, it is going to be AB over AC. Now for heights and distances, the most important trigonometric function that we will talk about is tan theta. Tan theta is generally useful for finding the slope, and slope of a line is vertical rise over horizontal run. So we want to denote the opposite side as rise, which is vertical rise, and AB, which is the adjacent side, as the horizontal run. Rise over run is tan of an angle. Tan of an angle for us is rise over run. So our rise is BC and our run is AB. So our tan function, which will be helpful in solving trigonometric in heights and distances problems. Vertical rise, which is the opposite side, here is BC, and horizontal run, which is the adjacent side, is AB. Now for us to talk about trigonometric functions, which is going to be useful for heights and distances, we are using tan of an angle. So let us consider our point of observation as point A and BC as some object. Maybe we could consider it to be a tower. So we are calling this as tower. So for us, BC is TOWER, tower. So if we want to talk about the point C, which is right at the top, and our point of observation was point A, thus for us to look at point C from point A, this AB is the horizontal, which is our line of sight. We have to look up here in this particular line. So this angle that we're talking about would become for us the angle of elevation. So therefore, in triangle ABC, we know we have considered BC as the tower. BC is height of the tower, which could be typically some number. We may consider it to be 100. So let's write 100 over here. This is 100 meters high, which is 100 meters high. So, our in this case, our angle of elevation, I will write here angle of elevation. So our angle of elevation is therefore in triangle ABC, our angle theta, or rather we could call it as angle A, which is denoted by angle theta, that is Greek letter theta, is our angle of elevation. Angle of elevation. So just the way we have talked about angle of elevation, we will also talk about angle of depression. When we refer to angle of depression, typically our line of sight is not at the lower side, rather it is at the higher side. So here we are considering point C as a point of observation. CD is the horizontal, which is the line of sight, which may also be called as the horizontal. So here we want to denote this as line of sight, line of sight. So for us, if C is a point of observation and we are trying to look at point A, which is below point C, thus we would be looking along this direction. Hence, with respect to CD, which is the horizontal, which is also our line of sight, this angle that we're making is going downwards. Thus, angle theta for us is angle of depression. So here I want to talk about angle of depression. Angle of depression, DE. Depression. Now, since we know that the horizontal, which is CD, or the line of sight, is parallel to AB. AB is the surface of the ground. Let's consider it to be the surface of the ground. Since these two lines are parallel and AC is acting as a transversal, hence angle of depression, which is angle theta, could be considered as angle A of the triangle ABC. So though when we talk about the angle of depression, which is angle made by AC with CD, so angle DCA is the angle of depression, but for our use we will use angle BAC, which will be theta, and this would be considered as the angle that we want to use or talk about. So let's say this is again maybe a pole, POLE. This is a pole which may have some height. Let's consider the height to be 50 meters. So now for us to use angle of depression, which is by taking alternate angles which are equal, so we know our angle is this. So here in this case, if I use tan function, so we will get tan of angle theta is going to be vertical rise, which is BC, over horizontal run, which is AB. So if we had angle theta, maybe angle theta is 30 degrees. Therefore, for us to figure out how far is A from B, we will use tan 30. So tan of angle 30 degrees is 50 over AB. But we know tan 30 is 1 over root 3. Thus, we will write 50 over AB. Therefore, AB is 50 root 3, which is 50 times 1.732, which could be written as 5 times 1732. Thus, on multiplication, we will get 0 here, 6, 1, 86.60 meters is the distance AB, Therefore, A is A is 86.60 meters away. from B. So this is the basics that will help us in dealing with angle of elevation and the angle of depression. Now we will go to the actual usage of the trigonometric function. Let's consider a problem. The problem here with us is, the problem says from a point 36 meters above the surface of the lake, the angle of elevation of the bird is observed to be 30 degrees and the angle of depression of its image in the water of the lake is observed to be 60 degrees. Here we should have degrees. Degrees is here. Find the actual height of the bird above the surface of the lake. So here we will have to use some bit of physics as well. So let's consider that this is the surface of the water. This is our surface of the water. So surface of water, H2O, surface. Since this is just plain water here. Now the problem says, or rather the question says, from point 36 meters above the surface of the lake. So this is point A, which is 36 meters above the surface of the lake. 36 meters above the surface of the lake. Let's consider this point as point P. Since we are measuring this as a height, so this angle B is making 90 degrees with the surface of the water, because that's how you measure the distance of a point A above the surface of the water or the surface of the land. And here it says the angle of elevation of the bird is observed to be 30 degrees. So which means from point A, if we consider this as the horizontal, which is our line of sight. I'm just writing line of sight. If this is the line of sight, at 30 degrees, the bird is spotted. So we make 30 degrees here. Let's consider that this angle is 30 degrees for us. So 30 degrees is spotted here. And this is the point where the bird is. So let's consider the bird to be here. So this is our bird. We want to call this point as P. So P is the point at which the bird is identified, which is at 30 degrees with respect to AD. We want to call this as D. Let's consider this as our point D. If we complete this is here. We want to call this as A, B, C, and D is here. So we know that the C is at 90 degrees with the base. So, and since we have considered this is the line of sight, it is parallel to the surface of the water. Thus, it should make 90 degrees here with PC. So ABCD is a rectangle. So we know that the CD is going to be 36 meters for us. So this is 36 meters. PD is some distance, some meters above CD. Thus, we want to consider this PD as X meters above D, above the point D, X meters. Now here in this case, the question further says, and the angle of depression of its image in the water of the lake is observed to be 60 degrees. So here what we want to really do is we want to use physics. So here in this case, if we use physics, we know that this is the height above which the bird is spotted, and this height technically is x plus 36 meters. So we know as per physics, for plane mirrors the image distance and the object distance is the same. So here we know that this particular point for us, let's change this distance for us is going to act like this distance for us is 36 plus x meters. So this point here, we want to call this point as point Q, which is the image of P. So we are referring to Q as the image of P. So this is Q here. P was the bird, and Q was the image of the bird. So this is the mirror that we have. The mirror is BC. So let's call this as the mirror BC. So we have precisely found the position of point, rather the image of the bird, which is at Q, and we know the angle that we are making from A to Q is 60 degrees. This angle of depression is 60 degrees. So now we are interested in finding out the height above which the bird is spotted. So the first thing that we want to do is we want to use tan function in triangle ADP. So here in triangle ADP, we know angle D is making a 90 degrees, is 90 degree. So here in this case, we want to use tan function. So since the angle is 30 degrees, so tan of 30 degrees is opposite, which is x, over adjacent, which is AD. Adjacent, which is AD for us. AD. And we know 30 degrees is a standard angle, and tan 30 is 1 over root 3. So we use 1 over root 3, which is x over AD. Therefore, my AD is x root 3. So we want to denote the AD distance as x root 3. So we are going to use this as x root 3 is this distance that we have figured out. This distance is x root 3. So since we know QD is 36 plus x, we are referring to this as 36, and this whole length is nothing but this length, which is x plus 36. So DQ would become 72 plus x. So now we're going to use triangle. Let's use this. We're using triangle in triangle ADQ. We're using tan 60. Tan of 60 degrees is opposite, which is 36 plus x over AD, which is x root 3. And since you know tan 60 is root 3, therefore root 3 is 72 plus x over x root 3. We will cross multiply, and therefore x root 3 times root 3 is 72 plus x. Therefore 3x, root 3 times root 3 is root 3 the whole square, which is 3. So it becomes 3x is 72 plus x. Therefore 3x minus 1x is 72. Therefore 2x is 72. Therefore our x is 72 over 2, which is 36 meters. Our x is 36 meters. So we were interested in height of the tree. So here we go. So here in this case, not the height of the tree, rather the bird, at the height above which the bird is located. So therefore the height of the bird above the surface of the lake. Height of bird above the surface of lake is nothing but PC, which is x plus 36, which is 36 plus 36, which is 72 meters. So my final answer is 72 meters. 72 meters. My answer is 72 meters. So bird is 72 meters above the surface of the lake is what we have figured out.